So as we look at notes 10.5 here, we are still looking at square roots and functions that have square roots, and we're going to talk about graphing them and what that looks like. So can I graph square root functions and identify the domain and the range? So if we look at our parent square root function, y equals the square root of x. Remember that when we graph any kind of equation, we can make a table. We can put values in for x and see what those y values are. So let's go ahead and just do that. Now, what I want us to try first is, can I put a -1 in the square root? You can't. You can't have the square root of a -1. It actually, it'll be an Algebra 2 concept where we look at what we call imaginary numbers. Okay? But for graphing purposes right now, we cannot put that -1 in. So let's go ahead and put 0 in. That's what we're going to start with. If we put 0 in for x, the square root of 0 is 0. So we're going to start right on our origin. I'm going to graph as we go. If I put 1 in for x, the square root of 1 is 1. So we're going to go over 1, up 1. Okay. If I put, I'm just going to jump to perfect squares. I'm going to go to the square root of 4, which we know is going to be 2. If I put 4 in for x, I know I'm going to be up to 2. And if I jump to 9, my next perfect square, I know that I get 3. So the square root of 9 is 3. And so this is what that graph is going to look like. Okay. Now, I want to talk about, because it also says to identify what we call the domain. That's your x values, and the range, which is your y values. Let's talk about what kind of x values did we put into our equation here. Our domain here is our x values are going to have to be greater than or equal to 0. So we can't have any negatives. So the domain would be our x's have to be greater than or equal to 0. And we found that our range for these values, what kind of answers are we going to get, is going to be the exact same. My y values are going to be greater than or equal to 0. Let's go ahead and move on to a couple more examples here. And we can make a table, plug values in for x. That's it. Now on this one, we're going to talk about what happens, and I'm just going to give you a little hint here. We're going to have a vertical translation. So we have our parent function. I'm just going to box it in red. There's your parent function, what we just looked at on the last slide. But we're going to add 2, and that +2 is not underneath the radical symbol. It's on the outside. So let's go ahead. We know that we cannot put a negative, so we're going to start with that 0 again. So if I put 0 in for x, I take the square root of 0 is 0 plus 2, and I'm at 2. So you're going to see that instead of starting at 0, 0 like our parent function, this is actually just shifted vertically 2 units. Okay. Let's go ahead and put 1 in. The square root of 1 is 1. And then plus 2 would be 3. So we're going over 1, up 3. And again, I want to stick with perfect squares. So if I put the number 4 in for my x, we get the square root of 4 is 2, plus 2 is 4. So I'm going to go over 4, up 4. And last, if I put the number 9 in for x, my perfect squares, the square root of 9 is 3, plus 2, I'm sorry, is 5. So over 9, up 5. And so you can see that our graph is the exact same as the one before, except it was just shifted up the 2 units. So whenever we have, if we were to add 2 units, or if we were to subtract 2 units, that would be, we're translating this graph vertically up or down up or down the y-axis. If we talk about our domain, the domain here, let's talk about what x values can we place in. Well, our x values are going to have to be greater than or equal to 0 again. Remember, we can't put negatives into that radical symbol. And what about my y values? What do you notice your y values? All our y values here are going to be greater than or equal to 2. They're all above that, greater than or equal to 2. Let's go ahead and look at, that's a vertical translation. How would this graph look any horizontally? This one's a little blurry, I apologize for that. If we move it horizontally along our graph here. So let's go ahead and talk about, remember that in that radical you cannot have a negative value. But if you notice here, it says the square root of x plus 3. That plus 3 is under the radical symbol. Let's start with a negative 3 here. What do you notice if we put a negative 3 in for that x? Negative 3 plus 3 is 0, and then we take the square root and we are at 0. So here we are able to put a negative value in for x because that sum is going to get you 0. So if I go over negative 3 on my graph and up nowhere, this is where we're going to start. So you can see that this graph is getting transitioned horizontally. Okay. So what if I put a negative 2 in? Well, we know that negative 2 plus 3 is a positive 1. The square root of 1 is 1. So I'm going to go over negative 2 and I'm going to go up 1. Okay. Now, let's go ahead and put in the number 1. And the reason I jumped to the number 1 is because I know 1 plus 3 is 4, and that is a perfect square. The square root of 4 is 2. So we're going to go over 1 up 2. And my next perfect square would be 9, so 6 plus 3. So I'm going to put a 6 in. 6 plus 3 equals 9. The square root of 9 is 3. So I'm going to go over 6 and go up 3. And so you can see the graph is very similar here. The only difference is it was translated horizontally. So it was moved along the x-axis. Let's talk about our domain and range on this one. This one's a little different. We're going to talk, our last slide is going to be how we can figure out that domain. So here we have all of our x values could be greater than or equal to negative 3. So we can put in values that are negative 3, negative 2, negative 1. And talk to me still about my y values. What kind of answers was I getting? I'm still, for my y values, I am getting answers that are greater than or equal to 0. Okay. So the domain can be challenging to figure out sometimes. And what I want us to remember is that we cannot have a negative value in our radical symbol. So that when we graph, if we want to find that domain, and I just gave a random problem here for finding the domain. Okay, what I want you to notice is that the 3x minus 9 is in the radical, and we want that to be bigger than 0. We don't want it to be a negative. So we can literally just go ahead and set the 3x minus 9 is greater than or equal to 0. We can set that greater than or equal to 0 and just solve it. Okay, we're going to add 9 to both sides. And so we have 0 here. We bring down our 3x. Our 3x is greater than or equal to 9. To get the x all by itself, we divide by 3. So if we ever want to find out what values we can place in for x, our domain for this problem would be that x has to be greater than or equal to a positive 3. So we could not put a positive 2 into this problem. We would get a negative answer and it would not work. Okay, so if we are finding the domain, we want to make sure that we set the radical just the radical. I circled it here. We want it to be greater than or equal to 0 because we don't want negative values, and we can solve and we can figure out what values we can place in there if we were going to graph it.